At this problem, we're looking at another example of 2D equilibrium. This will have its own uniqueness because, let's see, this said that there's find the support reaction at roller A and a smooth collar, so that's a difference. That's something uniqueness. Smooth collar B on the rod. The collar is fixed to the rod AB. However, you can't allow to slide smoothly along the rod CD. So if we were drawing our FBD first, let's consider at A is going to be a roller support, so you can move freely this direction. Then we won't have force at that direction. We're just going to have our force at this direction. Since you cannot move freely there, we can just draw AX. Then we have this external force 900. We also have another different feature for this problem. It has a moment. This is external moment. Yeah, that can happen. You can just apply a torque anywhere, right? So that's the external moment. Then we have this smooth collar, and it can move freely along this direction. See, if it can move freely at this direction, CD, so you won't have force at that direction. However, you cannot move freely at perpendicular, so we're going to have that. That's how we draw this reaction at the collar B. So I'm going to just call B. I'm not going to call BXBY because it's an angle, it's slanted. Also think about this. For the smooth collar, we're going to use our rule of thumb. If you cannot rotate, we're going to have a moment. Can this rotate? It cannot because it's fixed to this AB. And you can the only way of movement is translation movement along CD. So we're going to have a moment here. So we're going to assume the direction is going to be that direction. And that's what we call MB. That's what we're solving. And we also have reaction force B perpendicular to CD. That's what we're solving. We also have this roller support AX we're solving. Now that complete our FBD. Okay? So 3 unknowns and 3 equations. We are ready to get our equations going. Forces at X. Now let's see. If I go from right to left, so I have AX pulling to the left, so that's going to be negative. And I have this force B. B I'm going to decompose to X direction and Y direction. And since this is 45 degree, right? If that's 45 degree, then what do we know? This is 45. 45 is easy to do. If this is 45, that will be 45. That will be our 45 degree. Right? Because 90 minus 45 is 45, and this is 45 degrees. So it really doesn't matter sine or cosine. But now you're looking at X component, which is right here. So if we use, so either one, let's use cosine 45. Oh, I got on the wrong spot. So we're going to have this B, we're solving cosine 45. And it's pointing to the right, so it's positive. And I don't see any other forces that's at X direction, so that's all. Then we do forces at Y direction. Let's see. Forces at Y direction, we are going to look at B. B going to have a force at Y direction. It's B times sine 45. And it's going upward, right? So it's positive. Then we're going to have this 900 going downward. Then no other forces at Y, so that's equal to 0. The last equation is moment equation. And what do we do moment about? I think if we do moment about B, it's going to be easy. Why? You can choose that A have 1 force and B have 1 force, but B is slanted, right? So if I choose that, that's easy. Then I don't need to worry about BX and BY and their moment of arm. So now we choose B. So BX and BY will not show up in the equation because they all go through that point B. Then the next one is 900. Actually, hold on for a second. The next one is not 900. If I start with B, don't forget, since this is a collar, it cannot rotate. Remember, we're solving this MB. That is what we are solving. And I assume it's counterclockwise when I draw on this FBD, so that's going to be positive. Okay? Then we consider BX and BY. BX, BY will not create a moment at B. So don't forget what you're solving here. Okay? BX, BY don't show up in the equation because you choose point B. However, this moment still gonna be there in this moment equation. Then we have this 900. And what's the moment of arm for this 900? Because we're in moment equation, force times moment of arm is going to be times this 1, right? Because moment of arm, if I draw in purple, will be from B to this force right here. So that's 1. And that's going to be clockwise rotation, so that's going to be negative. Then, don't forget, there's another external moment. This 600, it's going clockwise rotation as labeled there, so it's going to be negative 600. So that's another uniqueness to pay attention. All right? Because why do we show up 600 in moment equation, not on X and Y? Because 600 is in unit of Newton meter. That is the moment. So only show up in the moment equation. All right? Then the next, we have AX, force times moment of arm. What's the moment of arm for AX? So if you were trying to extend this AX, then if I would draw using blue color, this is going to be my moment of arm. And what is that vertical distance? Then we're going to use the geometry here, right? This is 2 meter hypotenuse. And so this will be our moment of arm. So that's 2 times sine 45 degree. Now let's think about the direction. This force is going to rotating about B, and that is a counterclockwise rotation. So it's plus, all those equal to 0. So to solve this problem, you can either using hand calculation, or you can use the linear equation solver on your calculator or online. Here we're going to together on using online. So I'm on Wolfram Alpha. We're going to have the first equation. I have negative AX, right? So I'm just going to use A plus B, what we're solving, times cosine 45 degree. That equals 0. Then the next equation, we have B sine 45 degree minus 900 equals 0. Semicolon. Then we have this MB we're solving, so it's just M minus 900 times 1, then minus 600 external moment, then plus 2 times AX, which is A, times sine 45. So 2 times sine 45, then times your A. That equals 0. Let's enter, see what our input is, right? Okay, so M is a variable. Yeah, we do. M is a variable. So negative A plus B cosine 45 equals 0. That looks good. Everything here looks good to me. And let's see what we have. So they already have the solution in exact form, and then we can get to approximate form. So that's our answer for that. Let me take a picture. This one right here, right? So go back to OneNote. I have down, we got our AX, which is our A here. It's 900. And our B is 1272.8, and our moment is 227.21. Now think about the unit. For moment have to be Newton meter, and for the force is going to be everything in Newton. So that's what we have. You figure out the support reaction at roller A, which is 900 Newton, and at the smooth color B, you know there's a force B in this direction, you also know the moment in this counterclockwise rotation. That's all for this problem. Bye.